Welcome to another IB Environmental Systems and Societies video. Today we're going to review ESS topic 8.4, Human Population Carrying Capacity. We'll explore how many people Earth can sustainably support, what ecological footprints are, and why it's so difficult to quantify human carrying capacity. So let's get into it. A key significant idea for this topic is that human carrying capacity is difficult to quantify. Unlike other species, humans have complex impacts on Earth. As the cartoon shows, we can't simply ignore connections between population growth and environmental issues. This difficulty in measuring carrying capacity presents major challenges for environmental planning. Carrying capacity is the maximum number of a species that can be sustainably supported by a given area. For most animals, this concept is pretty straightforward. There's a limit to how many deer or rabbits an ecosystem can support. But for people, it's much more complex because we modify our environment and we import resources from outside our immediate ecosystems. Estimating human carrying capacity is problematic for three main reasons. First, we import and export resources between ecosystems. Second, we substitute resources when some become scarce. And third, we develop new technologies that change how we consume and use resources. These factors make our relationship with Earth's carrying capacity unique among all species. The ecological footprint, or EF, offers a solution. It's a model that helps determine whether human populations are living within their carrying capacity. Rather than asking how many people an area can support, the EF asks how much area is needed to sustainably support a given population. This reverse approach makes human impact measurable. An ecological footprint measures the area of land and water required to support a human population at a specific standard of living. It includes land for carbon absorption from fossil fuels, forests for timber, cropland for food, grazing land for livestock, fishing grounds, and built-up land. All these are measured in global hectares. The ecological footprint model helps estimate demands that humans place on the environment. It considers various activities like built environment, agriculture, fishing, forest use, grazing, and fossil fuel consumption. Remember, these activities vary pretty significantly between less economically developed countries and more economically developed countries. Generally speaking, the more economically developed a nation is, the higher its ecological footprint will be. Ecological footprints vary significantly by country and individual. Factors include lifestyle choices that are shaped by environmental value systems, productivity of food production systems, land use patterns, and industrial activities. If a population's ecological footprint exceeds the land area that's available to it, that population is living unsustainably and they're exceeding carrying capacity. Take a look at some global ecological footprints, and you can see some pretty dramatic differences between them. Countries with the biggest per-person footprints include Qatar, Kuwait, the UAE, Denmark, and the United States. African countries generally have much smaller footprints. These differences reflect consumption patterns, development levels, and lifestyle choices between LEDCs and MEDCs. Environmental degradation and consumption of finite resources will eventually limit human population growth. As shown in this image, pollution, resource depletion, and habitat destruction reduce Earth's capacity to support human populations. These kind of impacts create real limits to growth, even if they're hard to quantify precisely. If human populations don't live sustainably, they risk exceeding carrying capacity and collapsing. The graph shows how populations can overshoot carrying capacity, thus depleting natural capital and causing a population crash. That leads to a degraded carrying capacity, which makes it harder for future sustainability to be achieved. Rapid population growth creates challenges at multiple scales. Food supply, resource availability, environmental quality, and economic systems all face increasing pressure. Different sectors of society experience these impacts differently, and that affects international relations, and it creates both local and global consequences. This map shows ecological footprints by country, with darker colors indicating larger footprints. Notice how MEDCs generally have larger ecological footprints than LEDCs. This reflects differences in consumption patterns, industrial development, and lifestyle choices across different societies and economies. Environmental value systems also significantly impact ecological footprints. Different worldviews lead to different consumption patterns and environmental impacts. As the cartoon illustrates, short-term thinking about development can have long-term environmental consequences. Understanding these connections is really important for sustainable decision making. International mindedness connects to sustainability through global resource management. Resources don't respect national boundaries, and that makes cooperation super important. From a TOK perspective, measuring human carrying capacity involves both objective data and subjective interpretation. And this highlights how environmental science combines empirical evidence with value judgments. That's it for our review of ESS topic 8.4, human carrying capacity. Remember that an ecological footprint is a useful tool to assess sustainability and resource use. You should also explain how human behaviors that are different from other species are what make it hard to reliably calculate an ecological footprint for different societies. Good luck with your ESS exams, and until next time, happy learning.